Hello, everybody. So today in class, we're going to describe inertia. What is inertia? And then the second question you're going to answer in your do now is which basket would have more inertia and why? All right, so let me show you where this is located again. I know it's been a while. So let's see, we're going to click on that and we're going to come on over here to our Schoology. And here in the materials is always where our do now is. See, so here was today's do now, the 14th, and the slides that I'm going to be presenting. If you're ever not here, that's always there, and right here in the recording lessons is the lessons. Now, anything that we've done so far before break is in this folder, and then these are since we've come back from break. So I'm going to be including today a copy of the lessons. We have these all saved, so I'll make sure they get pumped out so you can all see them, because that's kind of concerning that they're not there, but we'll get them there. Also, if you want to redo the quiz, we'll talk on Monday about how you have to chart that in your grade book, in your notebook, and then you can retake the quiz. But that's what we're going to do, so let's get a hold of our slides for today. All right, so what is inertia? Well, we talked about that over the last couple days. It is when an object in motion stays in motion unless a force acts upon it to stop it or change direction. And then similarly, or the second part is, but an object at rest stays at rest until a force acts upon it, causing it to go into motion. So changing speed, more or less, changing direction. Those are changing its acceleration. So right now, we're going to take a look at our learning targets, which I will describe and use Newton's second law of motion. I can draw and use the F equals ma triangle, kind of like our other triangle. Calculate the force, the mass, and the acceleration. So right here is a great video about Newton's laws about forces when they're unbalanced and how that all plays out. You can click on this and watch this in the slideshow. But right now we're going to go to page 20 in your digital notebook. And let's take a look again at where our digital notebook is. So here under assignments, right here, unit force crash, you want to click on this link, open your digital notebook, and we're going to go to slide 20. So right now here, what we're going to do is we're going to kind of drag and drop here. So we're going to take this, because that's the best definition. Awesome. And some of you noticed that when we talked about, we have a large truck and a small truck, so that unbalanced forces are things that cause objects to speed up or slow down or change direction. So greater the force, the greater the acceleration. So if a large truck and a small truck, you're right. That large one goes here by the large box, and this small one comes on over here. That's great. Remember, force is mass times acceleration. So here are the three triangles, same setup, force, mass times acceleration. If I'm looking for mass, I have force divided by acceleration, or if I'm looking for acceleration, it's force divided by mass. And yeah, these are color-coded, so the yellow goes with the yellow. You're going to drag and drop like this. Just drag and drop them in there, just so you see that. What you're going to do here, though, on the next slide, which is slide 21, is we've got some sentence stems here. I'm going to give you a hint. The first two sentence stems are for this question. The second two are here. So let's do the first one. How is net force calculated when forces are applied to an object from the same or opposite direction? Well, when they're applied from the same direction, and we're just going to click in here, you can click in the same box, okay? And you can just simply just type the same sentences. So when forces, it's not going to let me do that. All right, that's okay. So what we're going to do is we're going to click in the bigger box, and there's my cursor. So I'm just going to hit my space bar, and now I'm going to start typing. When forces are applied in the same direction, comma, you, that's right, add them. Now, I'm going to check my spelling here. There's a little spelling, so I'm going to hit the click, applied. Of course I meant applied. So I'm going to copy this, and I'm going to paste it. I'm going to bring it down, because, we want to make sure we got it in here, so we get credit for it. So Control V. All right. So when forces are applied in, not same, but I'm going to change this to say in opposite directions, we absolutely, friends, subtract them. All right, so we got that done. Okay, oops, forgot my W. When. All right, and then here, it says, how does mass and force affect acceleration? So, well, let's take a look at that. So let's say when forces make the forces increase. So when we're pushing that cart like it's Costco or Sam's Club or Walmart, that big cart, it's empty. We can get a lot of force behind it because we've increased the forces and acceleration increases because there's not much there keeping us going. But when mass increases, oh, I see that hand. Oh, hold on. Acceleration decreases because now all of a sudden we're pushing this big object and heavy object. So yeah, that's pretty much the way it is. All right, so here, you're going to take these triangles from the slide or these formulas. So move this one back over. Move those over. Move these back. Oop. Move these back. Because I want you to be able to do this on your own in your own notebook. So you can do it. Okay? But we're going to use those triangles and we're going to use these formulas to help us here on this. This is slide 22 in your notebook. So what I want you to do is you're going to say force. Well, if I'm looking for force, okay, if I'm looking for force, I'm going to multiply mass, 3,000 kgs, times 2 meters per second. Now, you're going to use above the 6 is that little caret, and then that's going to tell me that that's meters per second squared. So 3,000 times 2, let's see, I'm going to bring that down, back, sorry, is 6,000 N or newtons. So what I'm going to have you do is I'm going to have you fix each one of these. They're even color coded so they would match that slide there, what you're looking for. So you can type that, or you got to show me some kind of work. So you've got to type, you got to like make a copy of that triangle, try and drag and drop it down. That's a little tough. Or you can simply type out the equations that are up here. And so this one would be F equals M times A. So see, look, you got that. And that's all you have to do. But I want you to do all 4 of these. On this one, we have the force and we have the acceleration right there. If there's decimals in your answer, please leave your answer in decimal form. Do not round. All right? Now, when you're done with all that, there's this really great video here from Newton's second law in action, and it's great, and it's done by NASA, so it's really cool. And then lastly, here's our exit ticket. A golfer hits a ball with a club. The mass, okay, so there's my mass, is 0.05 kilograms, and it accelerates at 2,000 meters per second squared. So I have mass and acceleration, so I'm going to do what with that? Okay, so you're going to do that, and that's your exit ticket. You can always check. All right, we will see you all next week. Have a great day.